Hello everyone. So in the previous class we have already finished the pre-body diagram, that is the frictional force and the pseudo force, then your weight, then your normal. So all are thing, all that means all are forces. So that we have discussed previously. So today, if you like the previous video, then please share, and if any mistake, please comment. So share this and subscribe the channel so that it will reach to everyone. So today we will study about the projectile motion. So what is the today topic? So this is projectile motion. Projectile motion. So this is the first word is the projectile. That means the body will be projectile. That means it will move in air. So the first of all thing, the body will move in the air with a force, with a initial velocity, with a final velocity, then it will reach maximum height, then also it will passes through a distance. That means a body will projectile. Projectile means if you are throwing an object from the ground level or from certain height, आप किसी भी कोई ऑब्जेक्ट को अगर ग्राउंड से फेंकते हैं तो एक इनिशियल वेलोसिटी देके उसको थ्रो करते हैं, फिर वो क्या करता है ना, वो ग्राउंड से जाके कुछ हाइट जाता है फिर नीचे गिर जाता है। नहीं तो ऐसा भी होता है, हम सीधा 90 डिग्री में बॉल को फेंकते हैं, फिर बॉल कुछ हाइट तक जाता है फिर नीचे गिर जाता है। तो ऐसे जो मोशन है उसको हम प्रोजेक्टाइल मोशन में कैटेगरी में रखते हैं। तो ऐसा है कि यहाँ पर एक हॉरिजॉन्टल रेंज है। सो दिस इज एन हॉरिजॉन्टल path, so that we call as our range. What we call it? It called as range. So there is an object, and this object was thrown from the ground with an initial velocity u. So what is u? There is a Newton. So remember, u is your initial velocity. Then it will reach a maximum height. So it will reach a maximum height, then it will come to the ground state. Okay, so this is one system of projectile motion, that the body will thrown from the ground. Okay, so this is the ground level and it will reach a maximum height. So this is the horizontal range, this is the range. So what is r? R is the horizontal path and the maximum is its range. Then the maximum height is h. So r is the path, okay, the horizontal path, how many distance the ball will travel, and h is the maximum height. Okay, u is the initial velocity. Then at a particular point we can take it, you can take the velocity v. Okay, u is the initial velocity, right? It is constant. Initial velocity is constant because it was given by us. Then the ball will fly in the air. What happened? Ball will fly in the air. Ball or object travel in air. So such type of motion we call as projectile motion. So v is your final velocity. Remember, these terms we will use. V is your final velocity. But this is not constant. Okay, so this is variable. That means it will depend upon this will calculate at a particular point. At a particular point. So what is v? Now v is the final velocity, and we will calculate the final velocity at a particular point. But u is the initial velocity that will be provided to the ball, so that the ball will move in the air, and it will go through a range, that is a distance. So if we are considering this distance, so this will be your r and this is your h. Okay, so this is the path, horizontal and vertical path. So u is the initial velocity and v is the final velocity. If you are considering this point, if you are considering this point, then what is the velocity here, then what is the velocity here, then what is the velocity here. So this velocity is vary. This means this velocity is not constant, so that we call the final velocity. Then the velocity has a different x component, y components, that's the different thing. So what is the second case? The second case is that a body, suppose a man is standing inside a, so here is the man is standing, and this is the ground. Suppose this is your house and the top one is your floor. तो ये घर का जो छत है वो ऊपर है, और उस छत के ऊपर एक आदमी बैठा है. तो उसने क्या किया, सो द मैन इन द roof of your house, he throw a ball. Okay, he throw a ball, then the ball will move, then it will goes to the top. So you are in, so this case is that you are sitting above a height h. You are sitting, that means the man is sitting above height h. This means this h is constant. So this is the wall height. Okay, so this is the wall height, and you are standing above the wall. A man is standing above the wall and he throw a ball. So the ball will move to a height h, then it will goes to the down. So this is the second case of some projectile motion. Then what is the third case? The third case is that a man is standing here. This is the ground. Okay, this is ground, and a man is standing here. He throw a ball just to downward. So this is another, there is h. So here what is, your initial velocity is 0 and the final velocity here is in the ground point. But here there is initial velocity, right? So there is initial velocity and there also final velocity. But in this case, your initial velocity is 0 because an object is dropped. An object is dropped from a height. So look to the three case. There is initial velocity and there are also final velocity. But the final velocity is not constant. You are throwing a ball from the ground. Okay, you are throwing a ball from the ground. So this is first case. And second case, you are throwing the ball but not from ground. This is from a height. So what is the first case? So the first case is an object has thrown from ground with initial velocity. Okay, so an object has thrown from ground with some initial velocity. What is the second case? So the second case is an object has thrown from a height. Okay, an object is thrown from a height with some initial velocity. So what is the second case? The second case is that the ball is thrown from a height, but this is the ball was thrown from a ground. And the third one I have written here. So this is the second one and this is the third one. An object is dropped from a height. Okay, so the first case is the object is thrown from the ground. So here the initial height is 0, but this is the maximum height. But here in this case the initial height is h, which is constant, that is the height of the wall. Then it is thrown to upward and the ball will, after some time it will reach to the ground. In the third case, the ball is dropped from a height. So remember, here the initial height, here the initial height is 0, here the initial height is h, here the initial height also h. Okay, so remember, initial velocity, final velocity, initial height, final height. So these are all difference. Okay, so this is the projectile motion. So one more thing here is the AR. Okay, so this is the maximum height and the maximum range. So the maximum range is the maximum horizontal distance and the maximum height is the maximum vertical distance. So there are some important things. So these are the three cases of your projectile motion. Then what are the important things? So try to remember, that is your initial velocity, final velocity, then your initial. So what is y? So y equal to h, that is your initial or final height, then your x, that is your range, that may be your initial or final horizontal distance. Okay, horizontal distance. So remember, these are the things. What is the initial velocity? What is the final velocity? Remember, initial velocity always constant, but the final velocity is variable. It can change. Okay, but the y, that is the vertical distance. This is the height. This is the vertical distance, and this is there is initial height and the final height. Here initial height is 0, so final is the maximum distance. Then your x is the range, that is how many horizontal distance it is travel. Okay, so these are the important thing about the projectile motion, so try to remember. Then what are the mechanics behind the projectile motion? So the second thing, what is the mechanics? What is the mechanics behind the projectile motion? So the mechanics is that. So what is the mechanics behind that? So we have, so what is the mechanics? What is, okay, so what do we have? So we have acceleration equal to velocity by time, because after acceleration we know the force. So what is the acceleration? Now acceleration equal to velocity by time. So what is velocity? And velocity equal to acceleration into time. So remember the case, that is the projectile motion. So this is the initial velocity. We have some initial velocity, and after some time it will reach to the final velocity. Oh, ribbon, ribbon. Okay, so let's erase it. So what is the mechanics behind the projectile motion? The mechanics that we have acceleration. Acceleration equal to velocity by time. We know this. So what is velocity? Acceleration into time. But in the mechanics case, we have write that v equal to u plus at. V equal to u plus at. So we know A is, remember, this is the acceleration. Okay, so this is the acceleration. What is the acceleration? Velocity by time. What is velocity? The acceleration into time plus u. Remember, when, why I have written u here? Why I have written u here? Remember, when t equal to 0, when t equal to 0, what will be? V equal to u. Okay, when t equal to 0, your v equal to u. Look to the case. This is the general case. Okay, there may be the height is 0, initial height is 0, but look to the case. When t equal to 0, we have initial velocity. That's why I have written u. Okay, when t equal to 0, I have initial velocity, v equal to u. That's why v equal to u plus at. So if you know the integration, okay, if you know the integration, what is the integration? Now acceleration equal to dv by dt. Then what is dv? dv equal to a dt. Then you integrate both sides, you will get v equal to at plus some integration constant, and that integration constant is nothing but the initial velocity. Okay, so what is the integration constant? The integration constant is the initial velocity. So here also same case. We cannot write that v equal to at. Okay, we know acceleration equal to velocity time, velocity equal to acceleration in time, but this is not constant case. This is not linear case. Okay, this is projectile. The particle is moving in the air. Okay, so what is v? V equal to at plus u. So remember, this is the first one. So v equal to at plus u. What is the second one? We have velocity equal to distance by time. So I have written in the unit dimension class, so all notification. This is velocity, this is distance, this is time. So what is the distance? This is equal to v into t. So what is v? V equal to at plus u into t. So this is also s equal to ut plus, okay, sorry. So this is at plus u. So s equal to ut plus at square. Okay, s equal to ut plus at square. Okay, so let's discuss more about this. That's ys equal to ut plus half at square actually here come. So remember, this is the first one. So what is the second one? What does it will be? Okay, remember, so when this case is different actually, we have two cases. That is for horizontal case. If we look to the horizontal case, if we look to the horizontal case, so what will be happen here? So this is the case. Okay, so this is the case. This is the horizontal case. So when look to the here initial distance is 0. Okay, so initial distance is 0. So what is the that means the body at t equal to 0, जब हम शुरू करते हैं तो पार्टिकल कोई भी पाथ नहीं, मतलब कोई भी मूव नहीं किया है, बस ऐसे है और उसको हम थ्रो करते हैं. सो वी आर थ्रोइंग विथ सम इनिशियल वेलोसिटी. दैट मीन्स इनिशियली द पार्टिकल इज एट ग्राउंड. Initially the particle is at a ground. So at t equal to 0, your s is also 0. Therefore, look to the velocity, that v equal to u plus at. That means there has some certain initial velocity, but there is no initial distance. Okay, so what will be s? S will be ut plus half at square. So what is s? So s equal to ut plus half at square. Right? Why I have written half at square? Because the time here, so this is the initial velocity and this is the time travel. So why I have written half here? Because the horizontal we are discussing, it is the maximum path. Okay, we are discussing the maximum path. We are discussing the maximum path because remember I have given one important point. We are discussing there is no air resistance. Okay, there is no air resistance. And what is air resistance? Air resistance is that, so suppose a body is moving to upward. Suppose a body is moving to upward. If you are throwing with some greater velocity, then it will go to maximum height. If you are throwing with a lower velocity, then it will go to lower height. Okay, अगर ज़्यादा फोर्स देते हैं तो वो ज़्यादा दूर जाता है और कम फोर्स देते हैं तो कम फोर्स थोड़ा दूर जाता है. सो दिस मीन्स देयर इज एयर रेजिस्टेंस. एयर रेजिस्टेंस क्या होता है? सो द एयर, दिस मीन्स दिस इज द एयर हैज अ रेजिस्टेंस. सो एयर विल अपोज द मोशन. दिस मीन्स एयर अपोज मोशन. What is the resistance? Resistance means so what we discuss in the frictional force case, so that a body will move, it has some friction, so it will stop after moving some distance. So same thing also here, air also has some resistance. When we are throwing a body to upward, air also give a force to restrict the motion of the object. That gets called air resistance. But in projectile motion, remember, in the projectile motion there will be no air resistance. If there is air resistance, then that case will be different. We will discuss if there is air resistance, what will be the equation of motions. That will be different, that we will discuss in the previous class. So today we will discuss the projectile motion with no air resistance. Okay, the projectile motion with no air resistance. If air resistance is there, then the all equation will be different. If the air resistance, okay, so we are discussing about no air resistance. So when in the no air resistance, note this, the time taken to reach this is the second case, the time taken to reach maximum height. The time taken to reach maximum height, that is t1, then to t2 is equal to time taken to again come to ground. Okay, that means T1 equal to T2. So remember, the time taken to reach maximum height is also equal to the time taken to reach maximum height to ground. That's why we have given one half side, because the initial path also is equal to the final path. That means यहाँ पर जाने के लिए जितना टाइम लगेगा, फिर यहाँ से यहाँ तक ग्राउंड में आने के लिए उतना टाइम लगेगा. So the time taken from ground to height is T1 and then from height to ground T2. So we are discussing this the general case. So that's why I have given one half side is there. So remember, the second mechanics formula equal to S equal to ut plus half at square. Okay, we will discuss the other case when there will be some height, then there will be some initial distance. Okay, so remember, this is the second part. Then what is the third? Okay, if you look to the integration also, what is the integration says? So integration says that your velocity equal to ds by dt. So what is ds? And this is equal to v dt. So okay, so what is ds? ds equal to v dt. So what is s? The s is integration of v dt. Okay, what is s? s equal to integration of v dt. So what is v? v is nothing but u plus at into integration of dt. So if you will integrate this, this will become ut plus half at square. Okay, so remember, this is also using the integration we can also find out the second mechanics formula, that is s equal to ut plus half at square. Then the third one. So what is the third one? So there is no resistance. So remember, so what is the first one? The first one is equal to v equal to u plus at. The second one equal to s equal to ut plus half at square, and the third one is v square minus u square equal to 2as. Okay, 2as. So b is the final velocity, u is the initial velocity, a is the acceleration, s equal to ut plus half at square. So s is the distance. This is the horizontal distance, maybe the vertical distance. Okay. Then fourth thing, remember, a equal to g if moving downward, and a equal to minus g if moving upward. What is g? The g is acceleration due to gravity. What is g? G is acceleration due to gravity. So this is the gravity acceleration. That means if you are throwing an object to upward, it will automatically goes to downward after some height. If you will throw a ball to certain height, it will reach the maximum height, then it will fall down. So who dragging the object? This is the gravity. Okay, so the gravity also pull every object to its center with a acceleration, and that acceleration is called acceleration due to gravity. So this is the gravity capacity acceleration. It pull every object to its center. So this is the acceleration due to gravity. So remember, when we are moving to upward, acceleration will be minus a, and when we are moving to downward, that means the earth center, the acceleration will be g. So these are the mechanics equations. Now we will learn some horizontal and vertical distance. So remember, if this is u and this is the theta, so remember, theta is the angle with the horizontal. Theta is the angle with the horizontal, and if we will do a perpendicular here, so what is your cos theta? So this is x and this is y. Then your cos theta will be x by u. So what is x? X equal to u cos theta. Similarly, what will be u? Y equal to u sin theta. So remember, this is horizontal. Okay. So remember, this is u. So u making angle theta with the x-axis. So this one will be your u cos theta, and this one will be your u sin theta. Remember this vector technique. So you have u that make angle theta with the horizontal, then the horizontal distance will be u cos theta, and the vertical distance will be u sin theta. Okay. So this is the vector technique. Now we will go to the first case of projectile motion. Okay, so look to the graph. The graph says that a projectile, that is an object, so that I have told so what is the dialogue, what is the dialogue behind this, that, so I am repeating the dialogue, so try to note it. Let us consider an object O. Let us consider an object O is thrown with some initial velocity u. Okay, again repeating. Let us consider an object O is thrown with some initial velocity u and making angle theta with the horizontal, So what you have seen, that there is an object and it has some initial velocity u and it makes some angle theta with the horizontal. Okay, so let r be the range of the object. That means this is the distance, this is the horizontal distance traveled by the object. What is h? This is the vertical distance traveled by the object, right? So let us consider an object is thrown from the ground with some initial velocity u by making an angle theta with the horizontal. Full stop. Let r be the maximum horizontal distance traveled by the object, and let h be the maximum height traveled by the object. So this is the dialogue. That means this is the theory. So let's go to the mathematical part. So what is u is your initial velocity, then theta is the angle made by object to horizontal, right? This is the angle made by the object to the horizontal. Then r is your maximum horizontal distance and h is your maximum height. So first we will take what is the time of flight. What is the time of flight? This means this is the time taken. This is the time taken by the object. To flight. Okay, so this is the total time. So time of flight, that means t is the time of flight. So what is the time of flight? Now this is the time taken to flight. That means to reach from O point to, this is an object actually, O is the object. So this point is A and this point is B. So that means A to B. To travel to A to B, how much time it will take. So this is the time of flight, right? So how much time the object O will take to reach from A to B. We'll calculate this time. Okay. So look to the maximum, look to this point. So let P is the maximum height point. Okay. P is the maximum height point. Right. So T, so what will calculate? So this is the total time of flight. Okay, so let P is the maximum height of the point. That means V is the final velocity at P. Okay, so v is the final velocity at p. So try to remember. So tell me, what is the theta here? What will be the theta here? What will be the theta here? So remember the initial velocity making angle theta with the horizontal. But this one, if this will move to this, then this one, this will move to this, then this one, if this will move to this, then this one. So this is the direction of your velocity, right? So this is your direction of your velocity. So what will be happen here in this case? Okay, so right up to this, that v is your final velocity at a point p. So I am starting from the top corner, so that will be easy to you. So we are calculating the total time of flight. So we are calculating what is the t. Okay, right, that is the total time of flight. So we have, remember, we have t1 equal to t2. What is the t1? Time taken from A to P. What is T2? This is the time taken from P to B, right? So this is the time taken from A to P, and this is the time taken from P to B. We have T equal to T1 equal to T2. That means this is the physics side when there is no air resistance. Okay, remember. So this is the time taken to reach A to P equal to the time taken to reach P to B, right? So what is V? We have V equal to U plus AT, right? That is V equal to U plus AT. But remember, we have two components of velocity. One is horizontal component and another is the vertical component, right? One is the horizontal component and another is the vertical component. So what will be your okay, we are discussing that is the time of flight. So we will take what is Vy, that is Uy plus Ay into T. So this is the vertical component. Right, so this is the vertical component. Okay, so remember one more thing, that is what is the theory. So write here the theory. What is the note? The particle, that is the object, is at rest at point P. So this is important. So note what happened at point P. P is the maximum point. If you will throw an object, then it will go to the maximum point, then it will stay, it will at rest on the maximum point, then it will move to downward with the help of the gravity. Remember, so this the particle is moving, then it will rest. जो ऑब्जेक्ट जा रहा है ना, वो मैक्सिमम हाइट पर कुछ देर तक रुकेगा. कुछ देर मतलब वो 1 सेकेंड का 60% या 70% से भी कम हो सकता है, लेकिन कुछ देर तक वो वहाँ रुकेगा. So the particle will be raised at point P for some very little time. At point P for very small time. Okay, so remember this. The particle will be at rest at point P for very small time. For very small time, the particle will be at a rest. So at point P, what will happen? At point P. Okay. So at point P, what is our final velocity? Our final velocity will be 0 because it will be at rest. Then what is our initial velocity? Our initial velocity at point P is the upward. That means this is the u sin theta, right? So this is your y-axis and this is u sin theta. What is the initial velocity? What is the initial upward velocity? This is, I have written uy. What is the initial upward velocity? Initial upward velocity. This is u cos theta, right? This is u sin theta. So what is the initial velocity? U sin theta. And remember, what is ay? We are moving upward, not downward. We are moving upward, right? the object is moving upward. So what is ay? Ay will be minus g into t. Sorry, t1. This is the time taken. So understand the last equation. I am again repeating. So t1 is the time taken from A to P. T1 is the time taken from A to P, and T2 is the time taken from P to B, right? So what is V equal to U plus AT? We know this. Then write the vertical component. Write the vertical component. So what is the vertical axis? This is the y. So Vy equal to Uy plus Ay into Ty also. Not Ty. Actually, this is moving from A to P. And this is the time from A to P. Okay, we are moving from A to P, right? A to P. So this is Vy equal to Uy plus Ay into T. What is Vy? Vy is the final velocity at point P. We are discussing this case at point P. So at point P, our final velocity is 0 because the final object will be at rest at the point P for a very less time. Okay. So at point P, velocity is, your final velocity is 0. Initial velocity, we are discussing the height case. So u sin theta. Your initial velocity at a y component is u sin theta. So u sin theta, then we are moving to upward, so it will be minus g, then t1. Okay, you solve this, you will get what you will get in t1 case. So in t1 you solve this, then you will get your t1 as u sin theta by g. So u1 is u sin theta by g. And T2 also same because we know T1 equal to T2. So what is the total time of flight? Total time of flight at T equal to T1 plus T2. So this is nothing but 2u sin theta by g. So this is the total time of flight. Remember, T equal to 2u sin theta by g. What is u? U is the initial velocity. What is theta? Theta is the angle made by the object with the horizontal. Then what is g? G is acceleration due to gravity. That value is 9.8 meter per second square, or generally we take it as 10. Okay. So next, we will discuss what is the horizontal distance. That means what is the range? Okay, what is the range? Again, look to the case that we have an object, we have a point A and another point is B. An object is travel like this, and we have some maximum height H, and we have some range R. Okay. So we have some range r, and this is the theta making angle, and we have some initial velocity. So what is the initial x component? U cos theta. And what is the vertical component? This is u sin theta, right? U making angle theta with horizontal, then this one will be u cos theta, and this one will be u sin theta, right? So this is y axis and this is your x axis. Okay, so how we derived the previous one? I am repeating previous one. So b equal to u plus at, right? So at point P, at point P. So यहाँ से यहाँ तक जाने के लिए कितना टाइम लगेगा? T1. यहाँ से यहाँ तक आने के लिए कितना टाइम लगेगा? T2. And we know T1 equal to T2, right? So for T1, that means it is moved to A to P. When it is moved to A to P, so your vertical distance, that means vertical component will be Vy into Uy plus Ay into T. What is the final velocity? 0. What is the y direction initial velocity? U sin theta. And then this is your Ay is your minus gt. Then you will solve this, then you will get this is T1, right? So what is T1? T1 equal to u sin theta by g, then that also equal to T2. So what is the total time of flight? 2u sin theta by g, right? So next, what is the range? Okay, so we have to find the maximum range. So what is the maximum range? For maximum range we have s equal to ut plus half at square, right? S equal to ut plus half at square. That just note that when we are moving from A to B, when we are moving from A to B, that means we are moving, so our AY can be G or minus G. But what will be the AX? The particle is moving from in the air, okay, right, in the moving in the air. So at point B, that means at point B, it will reach to ground. It will reach to ground, right? At point B, it will reach to ground. So what will be AX? Remember, AX is 0. So at point B, at this point, your AX is 0, right? So at point, so your AX is 0. So remember these things, that the particle is already reached to the ground, and when it's reached to the ground, your X component will be 0, right? So let's write the horizontal component. What is the horizontal component? What is the horizontal component? So this is equal to Sx equal to Ux into T plus half Ax into T square. Remember, we are moving A to B. So what is the time? This is the total time of flight, right? So what is Sx? What is Ux? Ux. So this is U cos theta, right? U cos theta into T, and your X is 0, so this is 0. So what is the Sx? Sx is the our range, right? So what will be the range? Now the range is equal to, okay, so what is the range? Range equal to U cos theta into the total time of flight. So what is the total time of flight? I am repeating again, okay, I am reading that. So what is the range? So we got the range as, what we got the range? Then the range equal to U cos theta into T. So this is U cos theta into T. What is the T? So T equal to 2U sin theta divided by G, right? So this will be U square into 2 sin theta into cos theta divided by G. What is 2 sin theta cos theta? This is nothing but U square sin 2 theta divided by G. So this is the maximum range of the, this is the range, that is the horizontal path. So this is the range. So what is the range equation? U square sin 2 theta divided by G. So this is the horizontal distance, okay. So let's go quickly to the vertical distance. What will be the vertical distance? What will be the vertical? That is the vertical part or vertical distance. What is the vertical distance? The vertical distance is h. So remember, t1 equal to t2, this is the time taken, but the capital T equal to t1 plus t2, right? So this is equal to 2t1 because t1 equal to t2. So what is the vertical distance? Again we have s equal to ut plus half at square. So we are writing the vertical distance. So for vertical component, what will be vertical component? The vertical component will be Sy equal to Uy into T plus half Ay into Ay, remember, Ay into T square, right? Okay, so what is the physics behind it? That remember, at the maximum height means what is the time taken to reach maximum height? Now the time taken to reach maximum height is t1, okay. But okay, so I am writing this. Remember, okay, so what is Sy? Sy is h. What is Uy? Uy is nothing but U sin theta. What is T? T equal to T1. I am writing T equal to T1 here because to reach the maximum height we need the time T1. So what is the vertical distance? The vertical component is your U sin theta into T1 plus half. What is Ay? So Ay is we are moving to upward, so this is minus G into T square. Okay, so this is the vertical path. So we are moving to the vertical one. That means we are moving to the maximum height, right? So this is the maximum height. Okay, so erasing this page. So what is your x? X equal to u sine theta, right? What is t1? T1 equal to, remember, to the time of flight s. So your t1 is nothing but u sine theta divided by g, right? U sine theta divided by g. Then the next case, this is equal to half, and g into what is it, t1 square. So t1 square, right? So u square sine square theta divided by g square. So this is the next equation. So why I have written t1 in the vertical component? Because this is the time taken to reach maximum height. When I have written a range, so the time taken is t1 plus t2, right? So this is the capital T. But in vertical case, to reach maximum height, we need the time t1. So if you solve this, this will give you u square sine square theta divided by 2g. So you solve this, this will give you this, because there is 1g and there is 2g. So 1g will be cancelled. So you subtract this, you will get u square sine square theta by 2g. Okay. So let's quickly discuss what we have discussed today. So we have discussed today what we have discussed today. So we have discussed what is the total time of flight. The total time of flight is 2u sine theta divided by g. What is the t? T is the total time. Total time of flight. Right. So this is nothing but this is equal to t1 plus t2, and in physics said that if there is no air resistance, then that will be 2t1. So what is t1? T1 equal to u sine theta, so 2u sine theta by g. Then what is the range? The range is u square sine 2 theta divided by g. Okay, so what is the maximum height? This is equal to u square sine square theta divided by 2g, right? So we have studied these three things today. So what is this? Is the total time of flight, and okay, so look to your diagram. So what equation we use this? We use this b equal to u plus at, and we discuss the y component, right? And in this case, what we use? S equal to ut plus half at square. But we discuss the x component, right? And remember, ax is 0. This is the a is the acceleration due to gravity, and we discuss it in the height case. If you are moving to upward, then minus g. If you are moving to downward, then this is plus g, right? And what equation we use this to solve? So this one we use sy equal to uy into t plus half ay t square, right? So this need us, that is the capital T we need, and this one we need T1, right? So this one we need T1 and calculate this, and this one we need capital T because the range is from initial to final, and this one is the time taken, that is T1 or T2, right? So remember, what is ux? Ux is nothing but u cos theta. What is uy? Uy is nothing but u sin theta. Right, that is theta. Theta, remember, theta is the angle of the object with the vertical. So this is T1. So these are the three things we have studied today. So try to remember this. So what is the total time of flight? 2u sin theta by g. And what is the range? U square sin 2 theta by g. And what is the height? U square sin square theta by 2g. And these are the equations we have did. And we have taken here the vertical component, here the horizontal component, because we have to find the horizontal distance. And this is the vertical component because we have to find the vertical distance. Okay, so remember, ax is 0. This is the acceleration along x-axis, and ay जो है वो प्लस जी और माइनस जी हो सकता है. अगर ऊपर जा रहे हैं तो माइनस जी, अगर नीचे आ रहे हैं तो प्लस जी. ठीक है. So these are all things we have discussed today. Okay, one important thing, that what is the R maximum? What is the R maximum? Remember, what is the R maximum? So R will be maximum if sin 2 theta is maximum. So what is the sin to theta maximum value? We know that sin theta का जो रेंज है वो -1 से शुरू होकर 1 पे खत्म होता है, ठीक है. So what is the R maximum? The R maximum equal to U square by G. Remember, this is R maximum. And when this will happen? When theta equal to 45 degree. Remember, if theta equal to 45 degree, then your R will be maximum. Because sin 90 is 1. We need this 2 theta. We need this 2 theta equal to 90 degree. So what is theta? Theta equal to 45 degree. So if you are playing the cricket, like if you are playing the cricket, so maximum distance. That means you can hit a 6 when your angle when your batting angle, that means your bat angle with the ground is 45 degree. So remember, if you are hitting the ball with 45 degree angle, then it will go to S6. That means a maximum distance. And when you will catch out, if you will catch out, that means if the ball will go to maximum height, then you will be catch out. So what is the maximum height? So H maximum equal to U square by 2G. Right? So what is H maximum? And when this is happen? This is happen when theta equal to 90 degree. Because there is sin theta, right? Sin theta square. Sin theta square. When sin theta will be maximum, if sin theta equal to 1. When sin theta will be 1, so theta equal to 90 degree. So if you hit the ball with the bat in 90 degree, then you will get maximum height. And if you hit the bat with the ball 45 degree, then you will go to maximum range. So this is the equation of maximum height and maximum range. Right? So when you will get maximum height? When theta equal to 90 degree. When you will get maximum range? तो theta equal to 45. अगर 45 डिग्री एंगल से मारेंगे तो बहुत दूर तक जाएगा, लेकिन अगर 90 डिग्री एंगल से मारेंगे तो बहुत हाइट जाएगा, ठीक है. सो इसको याद रखना. One more important thing, what is your H max? Remember, H max equal to R max divided by 2. So H max equal to R max divided by 2. So these are the important things. Try to remember. So we will discuss the second type of projectile motion in the next class. Okay. Up to this, try to read this. If any mistake or any problem, then please comment. And if you want the note properly, then please contact me. I have given my WhatsApp number in the previous videos. So look to the videos and then contact me if any mistake. And if you like it, then share, subscribe the channel, and also click the bell icon for new videos. Okay. Thank you. Jai Jagannath. So we'll stop here.